In this section, we're going to be solving word problems that will utilize systems of equations. The main procedure for solving these word problems is the same as they were in Chapter 2. We need to read the problems a couple of times, identify what it is that we are trying to find, assign the variables to the unknowns, create an equation, or in this case equations, and then solve and check our answers. So, let's go ahead and take our first example. Two numbers total 35 and have a difference of 1. Find the two numbers. So first we need to identify our two numbers, our variables. So we have a larger number and a smaller number, it says. So what I'm going to need to do is I'm going to need to assign my two variables. So I'm going to have an x and a y. So for x, I can go ahead and make that the smaller number. It doesn't really matter. And y, I'll make the larger number. So now I have identified my variables. The second step, since I have two variables, I need two equations. Well, I have two relationships in the equation. The first one is the two numbers total 35, which means when I add them together, x plus y, it's going to equal 35. They also have a difference of 1. So another equation would be, since it's a positive one though, I have to take the larger number minus the smaller number. So y minus x is 1. So this matters in this difference as to which number comes first. If this had been a difference of negative 1, then I could have done x minus y. Now, I want to use either method, substitution or addition. For this problem, I'm going to go ahead and use the addition method. So I'm going to rearrange these so that I have the letters lined up with each other. So I'm going to go ahead and take this first one and make it y plus x is equal to 35. Y minus x equal to 1 right underneath it. Because now I have the plus x and the minus x canceling each other out, equaling to 0. Because 1x minus x is 0. So I'm left with y plus y, which is 2y. 35 plus 1 is 36. Divide both sides by 2, and y is equal to 18. So my larger number is 18. Now I need to find the smaller number. Well, the smaller number, since the difference is 1 between 18 and the other number, the smaller number is 17. And 17 plus 18 equals 35, so it works for this problem. Let's take a look at our second example. Norman and Suzanne own 43 shares of a fast food restaurant stock and 77 shares of a toy company stock. At the close of the markets on a particular day in 2004, their stock portfolio consisting of these two stocks was worth $1,486. The closing price of the fast food restaurant stock was $22 more per share than the closing price of the toy company stock on the same day. So, we need to find out the price per share of the fast food restaurant stock, and we're also going to find the price of the toy company stock. Now this is what we call a value problem. Value problems always consist of a situation where you have an individual item that costs a certain amount or is worth a certain amount, and you have multiples of those items. Basically, take your shopping example. You need to buy something that's $2 and you need to buy 5 of them. So you take 5 times 2 and you're going to spend $10. So let's take a look here, and again we need to start by assigning our variables. So again, we're going to look for the toy company stock and the food company stock. So we don't always have to use x and y. So for example, I'm going to assign f to be the value or price per share of the fast food company. And T will be the price of the toy company stock. So there is our two values. The next thing we need to do is write our equations. Since this is a value problem, our main equation is going to be worth or deal with the total value. And that basically says, okay, I have 43 shares of the fast food restaurant. So I'm going to take the 43 shares times the number or the value of the price per share of the fast food restaurant. So the number of shares times the price per share. Let's take the other one, 77 shares times the price per share of the toy company. So we have 43 times F plus 77 times T. The value of both stocks is going to equal the total value of 1486. Now the second equation comes from here where it says that the restaurant stock was 22 more than the closing price of the toy company. So what we're dealing with is we're dealing with the fact that we have F, which is our price for the food company. There we go. And that has to somehow equal the price for the toy company. But they're not totally equal. It says 22 more per share than the closing price of the toy company. So the restaurant stock was, which is another way of saying is, 22 more than the toy company. So 22 more than the toy company. And again, all value problems will then have some relationship between the two variables that you came up with, but not specifically the total value. So in this case, the value price per share of each stock. Now I'm going to have you pause the video here and have you go through and solve this equation, see what you get for your answers, and then we'll see how you did. This particular equation is set up really nicely for substitution, so I'm going to go ahead and where f is, I'm going to replace it with t plus 22. Bring down the rest of the equation. Now I put the parentheses down here where the f was to make sure I remember to distribute. So 43 times t plus, now we need 43 times 22. So 946 plus 77t is 1486. Combine our like terms. 120t plus 946 is 1486. So subtract 946 from both sides, and we're going to get 540 is equal to 120t. Divide both sides by 120. And t in this case is going to be 4.5. So we now know that the price per share for the toy company stock was $4.50. Now the fast food here is $22 more than the toy company stock. So we simply take 22 plus 450, and that's going to give us $26.50 for the price of the fast food stock. This particular problem is going to make use of distance equals rate times time formula. For example, if you're going at 50 miles an hour, you've been traveling for 4 hours, you know that your total distance is 200 miles. That's what the formula we're talking about. So let's take a look here at our problem. Two towns are 1,050 miles apart. A group of hikers start from each town and walk the trail towards each other. They meet after a total hiking time of 200 hours. If one group travels 2.5 miles per hour faster than the other group, find the rate of each group. Alright, so what we've got here, if we need to see it visually, is basically we've got two towns separated, one group walking each direction. We'll call this group A, group B. And so their total distance apart at each town is 1,050. We know that one group is faster than the other. So for example, let's say that A is the faster group, and they're faster by 2.5 miles per hour. Okay. So let's go ahead and see if we can fill in our distance equals rate times time chart. Now, when you're doing a distance chart, you want to make sure that for each line that you have in your chart, that you have labeled what they represent. So in this case, I'm going to have one row that represents the information about group A and another one for group B. So let me start with the fact that I'm looking for their rates. So I'm going to assign group A to be X and group B to be Y. Or I could have simply done A and B. It doesn't matter the variables. Now, the time, we know that they were each hiking for 200 hours, so we know their time. The only thing we know about their distances is that the distance between the two towns was 1,050. So when they meet, combined, they will have covered the 1,050 miles. But we can't really put 1,050 in here because that's not the total distance that group A actually traveled. So we have to go back to this formula here where it says if you take the speed times the amount of time you've been traveling, you'll get the distance that you've traveled. So in this case, we will simply write 200x, which represents the rate times time of group A. And 200y is for group B. So now we have our chart filled in. Now we need to create our equation. Well, we know that their total distance was 1,050. So that means I could take the distance that group A traveled, which is 200x, and add it to the distance that group B traveled, which is 200y, and I know that the total distance that they traveled was 1,050 because they've met in the middle of the two towns. So there's my first equation. Now, I need a second equation that relates the value of x and y. So I'm going to go ahead and put x and y. Now, they're not equal speeds. We know that group A, which is the one I picked here, I said they were faster by 2.5 miles an hour. So what does that mean? Well, it means if I was to visually draw a rectangle that represents the amount of time group B took, and if these guys are, the speed of group B, and these guys were faster, so if they're faster, their rate is going to be larger, a larger number if they're faster. So if he was going, say, 2, they're going 4.5. So that tells me to make these equal, I'm going to have to do something to one or the other. So I said group A was faster, and group A for my work is x. So if these guys are faster, and I want to make the slower group equal, I would have to add to the slow group the extra 2.5 miles an hour. Now, since again x was my A, by adding 2.5, to this, I've now made the values equal. So those are my two equations. Now I'm going to have you pause and I'm going to have you go through and solve this problem, see what you come up with, and then we'll go through it. Now this particular one is also set up for good substitution, although again I could rearrange this and make it into an addition method problem. But I'm going to go ahead and just take that x is equal to y plus 2.5. Since half is a terminating fraction, I could change this to a decimal. So let's go ahead and take the first equation. 200, put parentheses in for x, bring down the rest of the equation. Take the y plus 2.5, put it inside the parentheses. Now let's go ahead and solve. So first we distribute 200y plus 500 plus 200y is equal to 1050. Let's keep going. 400y plus 500 is 1050. Subtract 500. So 400y is equal to 550. Divide by 400. And I will reduce that y is going to come out to be, let's see, if I divide by 10, I get 55 over 40. Divide each of those by 5, and I get 11/8, which is 1 3/8. So I have found that y, which is going to be my group B, which is my slower time, so group B traveled at 1 3/8 miles per hour, while group A traveled, so we need to figure out what group A traveled at. So here's my sentence. Kind of messed up here. A little tight. So the idea is, if it's 1 3/8 for the one group and the other group was 2.5 more, I'm going to take 1 3/8 plus 2 1/2. My common denominators, I get 1 3/8 plus 2 4/8. So the other group is 3 7/8 miles per hour. So group A traveled 3 7/8 miles per hour. Oops. Slide that back up here. Okay. So again, the idea is when you have a system of equation problem, it's because you're looking for two different items. You need two different variables. When you're solving with two variables, you must create two equations. So you're looking for two different relationships. As you work through these, you're going to start to notice the patterns of the different types of problems that we do. And once you start getting that idea, it's going to come a lot easier to work through these problems.